Masterclass hosted by Havana Capital in collaboration with the Council of Energy, Environment and Water. I am Shruti and I will be your moderator for today's session. We're hosting today's Masterclass as a part of the Havana Startup India Niti Aayog Atal Innovation Mission Grand Challenge for Climate Tech Innovation 2024-2025. This one of its kind initiative aims to identify and support climate tech innovators and startups who are driving transformative innovations in clean technology, sustainable agriculture, deep tech, green manufacturing, etc. The Grand Challenge offers several benefits such as monetary rewards, mentorship from industry leaders, and a chance to showcase at the Startup Mahakumbh, the biggest startup event in India. If you want to be a part of the Grand Challenge, click on the application link that we will be sharing in the chat. And for any latest updates, don't forget to follow Avana Capital on LinkedIn. So coming back to today's masterclass, the topic for today's session is opportunities in clean energy supply chains, manufacturing policy and innovation for climate action. This session will delve deep into India's clean tech ecosystem, covering subjects such as key policies, emerging technologies, and innovation trends that are shaping India's energy transition. To ensure a smooth session, I will request everybody to kindly stay on mute. To make this interactive, I will request all participants to drop in their questions in the chat box and not unmute themselves. I will be collating all questions from the chat box and moderating the floor. Our speakers today are Abhinandan and Shruti, both research analysts at the Technology Futures team of Council of Energy, Environment and Water. Abhinandan and Shruti, thank you so much for joining us today. Over to you.
Thank you. Thanks for the introduction. I'll just take a moment to share my screen. Great. If everyone can see, then I can begin.
Yes, we can see it, Shruti.
Awesome. Okay. Hi, everyone. Thanks for making it to our session today. My colleague Abhinandan and I will today be speaking about opportunities in clean energy supply chains, manufacturing policy, and innovation for climate action. A quick introduction before that. Abhinandan and I, again, are both research analysts at CEEW, the Council on Energy, Environment and Water, where we use data, integrated analysis, and strategic outreach to change the use, reuse, and misuse of resources. We aim to achieve certain transformations across energy transitions, industrial sustainability, amongst others, and want to improve the quality of life as sustained by clean air, water, food systems, etc., through important enablers such as sustainable finance, circular economy, and technology features, where Abhinandan and I both focus. Along with these teams, we have some special initiatives such as the CEEW Center for Energy Finance, Powering Livelihoods, Emerging Economies, and a state office in Lucknow. We are expanding with a multidisciplinary team of more than 330 people with more than 460 publications, and we continue to expand these impact numbers. So coming to the largest, most overarching theme that will inform everything we discussed today, which is why do we need to get to net zero? And why is this problem more intricate than we may think at first? So currently, climate change is not just an environmental issue. It also affects our health, our livelihoods, and our national priorities. Science has shown us a very clear link between increasing temperatures and emissions, and hence there is a need to curb these emissions in order to tackle the most extreme events that we are facing today. However, one of our most important problems lies in decoupling these emissions from economic growth. Science also shows us a very clear link between economic growth and emissions growth. Countries that are increasing their GDPs rapidly are facing higher and higher emissions. Especially the global south can be in a disadvantageous position due to this, and hence the Sustainable Development Agenda emphasizes decoupling these two things. Now, to understand where our efforts need to be targeted to tackle the climate change problem and the emissions problem as quickly as possible, let's take a closer look at what causes our emissions. This chart represents emissions for India in terms of carbon dioxide equivalents in billions of tons. And generally, seeing the trend up till 2018, we see that about 80% of all the emissions in India are attributed to the energy sector, where fossil fuel combustion is a very important driver of emissions. So, to sort of hit the nail on the head, emissions from fuel consumption and energy consumption and generation are where we need to focus our efforts. And hence, a large chunk of today's presentation will talk about the energy transition, its role in tackling the climate change problem, and how technologies can play a very, very important role in cracking and accelerating the energy transition. So, like I discussed, to deal with this issue, we need accelerated deployment of clean energy technologies, and the technologies that need to be deployed also have to be manufactured. Hence, there exists very small and opportunistic pockets where if we tend to manufacture certain products, we can unlock not just opportunities for decarbonization, but also economic growth. We'll discuss some of our insights on that. I'll let Abhinandan take that up. But briefly touching upon the technologies we'll be speaking about today, solar modules, lithium-ion batteries, and wind generators. It would be the rapid deployment of these technologies that will help India achieve some of the targets it's setting. For example, our nationally determined contributions to UNFCCC include reduced emissions intensity of the GDP and curtailing the emissions from the electricity generation sector. These are our targets for 2030. Very soon, we'll also be releasing targets for 2035. And we are hence very, very committed to achieving the climate change targets. Passing it on to Abhinandan.
Thanks, Shruti. So, as Shruti has already mentioned, we'll be dealing with solar PV, wind, and battery technologies. But firstly, I just want to give an appraisal vis-a-vis how we are doing in these technologies and essentially how CEW informs our work when we talk about uh, integrating these technologies at the intersection of policy as well as innovation. Uh, Slide, please. Yeah,
Just a
next
second.
slide. Yeah.
Yeah. Yeah.
So basically, when you talk about deep tech, it's a wider ecosystem focusing on science and technology, but wherein the perpetrators, the participants, as well as the ecosystem players tend to derive their value primarily from innovation, investing in high capex projects, stuff like that. But clean tech is a subset of the deep tech ecosystem in which the primary objective becomes climate action. And ergo, we focus on technologies such as carbon capture, clean energy, sustainable mobility, etc., which also have demand side impetus to it because of the wide uptake amongst consumers, but also supply side imperative from the government to do action on the social, economic, and policy front. And so as clean tech becomes a very important part of the whole deep tech ecosystem in India, which is also receiving a lot of traction in the last few years. Next slide. So there is an amalgamation of three aspects vis-a-vis how technology is upscaling in India. First is policy, second is private capital, and third would be international cooperation. On the policy front, the government is being very proactive with recent budget announcements such as on the National Manufacturing and Critical Minerals Mission, the Bharat Trade Net, the reduction in custom concession of various input materials that may flow into India now without any duty, and also the announcements that the critical mineral missions will undertake various new sub guidelines and policies, which were also mentioned in the union budget. This becomes important because the government is looking at this from a value chain perspective and not in silos. So, if critical mineral policy is being strengthened, that means manufacturing of all the products that are either included in PLI or are otherwise climate tech products will be strengthened because you're looking at the upstream. Similarly, there are various startup ecosystem players in India which are dealing with the midstream technologies. And obviously, end products are also being manufactured and assembled in India, and the policy caters to that. The success of PLI schemes essentially depends upon a whole of government approach, and therefore, policy herein becomes very important. Second would be the private capital. VC funds, PE funds, as well as banks are readily trying to gauge the sector in terms of investment opportunities, and India has become one of the top 10 investment destinations from energy transitions perspective. Uh, we have collectively raised 663 million US dollars in venture capital money and private equity money. So therefore, P and VC money is flowing into the ecosystem. And especially with respect to energy transition, we are seeing an increase in specialized funds which deal specifically with energy transition as well as deep tech. and clean tech, and also focusing on technologies within clean tech which are high uptake, such as mobility, as in clean mobility, and various startups related to two-wheeler and three-wheelers, energy efficiency startups which integrate AI technology with the physical assets that are available at our homes, and also tools and companions which are working on the power sector, vis-a-vis integrating these technological systems with the Indian grid. Uh, can you just go back? I think last slide. Yeah, and the last would be international cooperation. Because technology is not present in silos, there is a huge upside in interacting and collaborating with the national players through quadrilateral dialogue such as Quad, through IPEF, through Mineral Security Partnership, in which India and like-minded Western countries are mobilizing capital finance as well as technological diffusion tools, so as to make sure that ecosystems are strengthened in each other's countries. Moving forward. Now, this becomes very important in terms of how we look at the market sizes of various frontier technologies, so to speak, which includes certain green technologies along with IoT, AI, and other things. And we can see a substantial part of it would essentially currently is also solar PV, wind, EV, green hydrogen, etc., which is clean tech. But in the future also, it will form an important part of what we call as a frontier technological ecosystem. Referring to the previous slide, intersection of policy as well as international collaboration becomes utmost important when we are talking about frontier technologies, because the synergies cannot be understated in terms of knowledge spillovers as well as productive know-how as to how these frontier technologies will impact other sectors of the economy and spur manufacturing growth in India. And so as to see this slide, the market size essentially will be very important for clean tech in this regard. Moving forward, India is also a major player in clean technologies with almost $9.4 billion worth of market as of 2023, but it will grow tenfold in 2035. And that becomes very important from a comparative context because the Chinese market will be tenfold more than the Indian market. So in a global context, the clean energy market is smaller compared to other developed markets such as China, North America, and Europe. But India in itself will scale up hugely, seeing an exponential growth of 10 times. Public finance has also greater load to play because almost $4.5 billion over a time span of 5 to 6 years has been mobilized by the government through PLI schemes on solar manufacturing as well as batteries. So we see that the market has recognized the size and scale in which clean tech will operate in India. The policymakers have also recognized the need for pumping in public finance as well as policy levers and incentives that will lead to growth of the sector. Moving forward. Now, an important aspect as to wherein CEEW's work also comes in is the green window of opportunity, as in how CEEW views India's current position in clean technology manufacturing and how we think certain interventions are required so that we may leverage this opportunity to become a bigger, better market and a stronger player in the global ecosystem. Moving forward. So India is the leading market with fifth largest private climate funding with USD 2.2 billion plus. An important point to raise here is that we have 19 out of the 37 global climate IPOs with certain important examples such as Ola Electric and Vari Technologies, which have become case studies in themselves in the global private markets as well as public market as to how India has rapidly scaled up clean tech in the past 2 to 3 years. We're also seeing that there are more than 800 operational climate tech startups working in India, and therefore the ecosystem is very robust, as well as uh, uh, depending on the various incentives that the government is undertaking under Atal Innovation Mission or under the aegis of Niti Aayog and BIRAC, etc. There is a huge upside for investments into these 800 startups. And raising from seed to Series A, this will become important in the coming years because many of these may eventually go on to become big players in themselves. Moving forward. Yeah, so this is where CW's work come in. We have basically done research in field of how clean tech can impact India. And what we have seen is that there are certain components within the clean energy supply chain of solar, wind, and batteries, which are inherently more complex compared to the other components. And what this complexity essentially does is that uh, it makes for very high level of productive know-how that is needed to make these components. And this opens up opportunities for new components in the value chain, and therefore new manufacturing can come up. Also, in all of these components, there are certain components in which India has already an existing comparative advantage, and if we utilize and build upon that, we can see multimodal growth in these areas. I'll just give an anecdotal example. Solar cell and module are inherently complex products that are to be made by few countries itself, and India has seen exponential growth from 2014 onwards, in which how many solar modules are being produced in India. Current capacity almost hitting 80 gigawatt. Similar modes and pathways can be seen in other technologies as well, and clean tech would be encouraged in the future to pursue these technologies and with a combination of two factors, leveraging India's competitive advantage and seeing if these complex products can lead to opening up of new avenues and new value streams for the industry. Moving forward. Yeah, so CEEW had analyzed 20 different supply chain components for solar, wind, and battery. And what we saw was that as the global economy increasingly orients itself to be green, there are certain components in which they have complexity and opportunities for change. And that can be undertaken into three buckets, moreover. And that is that in which India already has export competitive advantage. The second would be in which India can achieve export competitiveness in the short term. And third would be technologies or supply chain components in which India may have a long-term stance in operationalizing and scaling up these so that we may structurally transform our manufacturing. And the segregation of these technologies, you can see, has led to certain components being highly valued. For example, it makes strategic sense as well as sense in terms of industry and leveraging India's existing capability is if we go for manufacturing of, for example, junction boxes or wind turbines, which are used in clean tech deployment. It also makes sense for the long term to invest in lithium ion batteries, as they can lead to structural transformation of the manufacturing sectors because they have spillover effects in other sector, and they can be used for EV adoption in the future and decarbonization of the transportation sector as well as the grid. So these insights can be very helpful in evaluating some of these areas where we can double down and therefore allocate more resources compared to other areas. Now I think I'll pass on to the next slide. Yeah. So there are certain emerging areas and emerging startups for opportunities in clean tech that can be related to energy storage, smart grids, thermal batteries, uh, rare earth magnets for EVs, new technologies for solar such as perovskites, system integration of battery technology into the Indian grid, and therefore integration of AI tools as well, so as to create a unified interface for energy and energy infrastructure, which is more robust and more interactive going forward, and which can create new streams of value. Complementing that would be emerging areas wherein India is already seeing advancements which can be termed as novel as well as innovative. Giving you an example of certain startups such as Chara Motors, which specifically focus on rare earth free batteries which are used in EVs. So basically, trying to reduce our supply dependence on Chinese rare earths because they have a leverage on that market, and trying to build up indigenous EV powertrains which can utilize those EV motors. Another example for that would be Kankiri, which basically works on innovative materials that are used in batteries. And these materials have low carbon intensity compared to what is present in the international market, garnering them a sort of a tag of a clean materials company rather than a dirty materials company, which we see is the benchmark which we are seeing in the Chinese market. Another important company which we can look at would be Loham, which is a pioneer and market leader in recycling of lithium-ion batteries, and their proprietary technology has been accepted globally and far and wide. So much that they export recycled battery materials such as black mass to the European market as well. And so they add value in terms of indigenization of technology as well as becoming an export-oriented uh, company and helping the Indian exchequer in that process. So these are the some emerging areas of opportunity which other startups can also learn from, and that may help them in leveraging the incentives that the government is providing, as well as catering to the markets of the future that will be low carbon as well as less dependent on concentrated input imports from countries such as China. Now I'll hand over to Shruti to lead the next section. Yeah.
Thanks. So, having understood the climate change agenda and the role technologies will play in solving for the same, as well as where are the most opportunistic parts for innovation, I'll now pull together the insights and try to build a consensus on what it means to make in India at this moment in this sector. What is the shared vision for the future that policymakers, innovators, and entrepreneurs can have as they try to build in India? We believe that an India plus many pathway is the key to this green future that we envision, where India taps into the collaborative opportunities and leverages the comparative advantages it has, as well as those of other countries, to build an inclusive and green future for all. So, the first thing is that export markets will play a very important role in helping clean tech startups in India scale. As we briefly touched upon the market sizes for these products, there will exist a much larger market for these products outside of India as well. And to achieve economies of scale, export markets can be tapped. However, tapping them widely and strategically will also be important because increasingly export markets are becoming different in terms of environmental regulations and consumer behaviors. While consumers in India can be more cost sensitive and green premiums might not be accepted here, the same is not true for consumers abroad. And hence, while exports will be very important, the strategies for tapping the domestic and international markets will be very different. ESG integration is also becoming a very important trend where the embedded emissions of any product are getting more and more attention, and that is one of the focus areas in tandem with making products cost effective and affordable. Because if only the products are cost effective, the deployment will be accelerated and we'll be able to get closer to our climate goals. So along those lines, cost competitiveness will also be very, very important. The next takeaway that we are observing is that technologies are increasingly converging in sense of the hardware and software they can utilize. And hence, industrial co-development is a very important trend. The biggest case study in the same is industrial co-development in China, where so many startups are working at the intersection of frontier technologies. As we can see in this chart here on the left, manufacturers are working across key sectors such as smartphones, semiconductors, electric vehicles, batteries, drones, autonomous vehicles, and AI. And there are many, many knowledge spillovers, like we discussed previously, that can be tapped. If you make one product, it can open pathways to making many other complex and futuristic products due to shared manufacturing processes, shared materials, shared basic principles of engineering, and hence tapping into one market can lead to pathways towards many others. So as we look forward to developing these technologies, the opportunity cost of not tapping these structural transformation opportunities will be huge. And hence, there exists a huge potential of tapping and entering many, many frontier technologies at once. This is why inter-industry collaboration in India will be very, very important, as well as industry academia collaborations where a bidirectional flow of information can be there, where industries give feedback from the market for what needs to be innovated and improved upon, and academia can do the same and supply the latest and the most innovative products to the industry for scaling up. At the same time, as we discussed, that there are many, many important resource dependencies and overcapacities in the global market. Here, international collaboration in ensuring inclusive and sustainable development pathway will be very important, where competition and collaboration are balanced. Hence, These multi-level collaborations will help us in pursuing this industrial co-development pathway where we can target multiple frontier opportunities together. Now, briefly expanding on the international collaboration part, as we see that due to high import dependence on many minerals, we are trying to collaborate with other countries. Similarly, there are gaps that exist in capital goods and in equipments that need to be procured in larger quantities to enable scale, in testing infrastructure and advanced manufacturing equipments. So all of these manufacturing enablers, capital, entrepreneurship, besides those, need to be brought to India and made in India. And there is huge policy interest in doing that and furthering the share of manufacturing in the economy. Hence, a strategic collaboration is needed in transferring technologies, in building more resilient and more diversified supply chains, and ensuring resource security. Hence, pooling resources and managing risks and developing multi stakeholder relationships will be very important, both for businesses as well as governments. Pulling all of these insights together, we see an India plus many pathway being the best, most opportunistic, and the least risky pathway that both governments and businesses can work towards together. With that, we conclude our presentation. Thank you for attending, and we can now take questions.
Great. Thank you, Abhinandan. Thank you, Shruti. So we've collated a couple of questions that we received through the Google form. So maybe we can start with that. And meanwhile, as I've mentioned, if you all have any questions, please put it down in the chat box. So I think the first question is more towards, green hydrogen promises a lot, but sometimes, falters from a practical perspective, perhaps. So which industries, according to you, are primed to adopt it as early adopters?
Yeah, so green hydrogen is a topic of contention as to its market maturities has not reached its peak, but the policy impetus and policy support that it has been receiving has been disproportionate to the market action. But still, there are certain use cases in which green hydrogen can be scaled up, and certainly there are captive use cases in green steel. Uh, as well as green ammonia. For example, I'll just give an example of green steel in which it can be captively used to make low carbon steel, which will be acceptable in new market such as Europe, which will eventually have the CBAM rules in place. And those rules require you to import a certain level of embedded emissions. There is a threshold, and if India is able to integrate the green hydrogen ecosystem with its steel production, then maybe we will have greater access to that market as well. Because there are certain entry barriers that will be assigned to certain products going to the future, especially from matured European and Western markets. The use case for green hydrogen in the short to medium run would be captive to industries which are high energy intensive industries and which have been the early adopters for the same. So green hydrogen, green ammonia, given the two industries. Yeah.
Got it. Thanks, Abhinandan. I think the other question is then, in terms of low-hanging fruits in energy transition, what do you think we can learn from European models of probably renewable adoption?
I think Shruti, you can take.
Sure. So in the Europe, very similar pressures of competitiveness in building clean tech are also being faced. And while the deployment is one angle, the manufacturing angle is the one that is of very pertinent, requires a lot of focus at the moment. Even in Europe, there are lots of lags in terms of achieving competitiveness. While Europe has a very well flourishing innovation ecosystem, there are still lags in taking the innovative technologies and reaching commercial scale. And we are seeing lots of examples where startups that were trying to do that have been failing due to their inability to anticipate lots of trends that are happening in the market. Because lots of end uses are also evolving. For example, batteries that go into EVs and energy storage systems. In those sectors, energy use, product adoption, the different chemistries that are playing out in the market, EV sales, etc. Many variables are there, many unknowns are there that are evolving. And hence, scaling up and manufacturing end of things still remains a bigger issue. So that will require focus from us. What India can particularly learn from there, the biggest missing gap, I would say, lies in innovation ecosystem as well. In India, we need to foster these innovation ecosystems, build better industry academia relationships, and tap into that bidirectional flow of information between the two. That will help us accelerate and take a lead in being competitive clean energy technology manufacturers.
Got it. Okay. I think the next question we can take from the chat. Rajhans has asked that, what are your views on carbon credit market? How is it shaping up and how big of an opportunity is there for carbon capture projects?
I think there are two different questions. Firstly, answering to the carbon credit market question. So, mm, certain countries and jurisdictions have adopted it radially, China and Europe, so to speak, being the first ones. In India, we have done piloted and some voluntary markets are operating in those terms. But the governance ecosystem for a nationwide carbon market is still in nascent stages and under development. That would be the answer to the first question. The second would be opportunities for carbon capture project. So carbon capture projects essentially are also being envisaged in industrial use cases. Because the technology has still not reached a maturity level, there are pilots being carried out, but more capture carbon offset projects in India are making more sense, and we have seen startups garnering funding based on that. And there are also existing ecosystem and existing deep tech startups which are focusing on utilizing the opportunity to create an offset market for various players around the globe as well as in India. I think that would be more of a big bet for India compared to carbon back capture because that needs a few more years to reach maturity.
Adding to this, in India, both in terms of voluntary and compliance carbon markets, lots of interesting developments have been taking place, especially in compliance markets, where the government puts a cap and trade. There have been interesting pilots going on in Gujarat, for example, where we try to run India's, rather the world's first carbon market in particulate matter, going to the PM 2.5 level. So carbon markets are also a very interesting case study in where technology plays a very important role, but so does policy in regulating, putting a right price, allocating the initial set of credits and regulating and implementing that. Continuous emissions monitoring systems, SEMS machines are also very important in accurately measuring, and hence technology will play a very important role in pulling the entire ecosystem together. This again is one of the areas where we can learn from the Europe. The EU emissions trading system has been very promising. But the main issue that remains till date across the globe is ensuring the verifiability and credibility of these credits, making sure that the additionality norms, etc., are all fulfilled. That's something I still see Indian startups sort of struggling with. So I think the first principles have to be cracked and validated, and then we can go further from there.
Okay. So the next question is, for emission transition of hard to abate sectors, how can India, take towards an early mover advantage?
Do you want to take this part of it?
Sure. So in terms of first mover advantages, we can look to emerging technologies. For example, alternative chemistries, let's say sodium ion, that show a lot of promise. There are many reasons why some alternative technologies may work well in India due to resource endowments and existing similarities, like we talked about tapping into inter-industry collaborations. So there are many shared processes and similar materials that are already there in existing Indian industries that can be used in producing certain products. And many alternative chemistries and next generation products are such that they are not currently under geoeconomic scrutiny. There are not as many tariff barriers, as many restrictions uh, there. So there are some pockets like these where India can take a first mover advantage if we try and build, but that's still a longer shot, still a decade of work to do. More immediately, like we discussed in the presentation, there are parts of the supply chains where components need to be made instead of making the entire product, instead of making the entire solar module. There are complex components, very sophisticated components that have to be made that can also be traded. There is a demand for them in the global market that India can benefit from manufacturing domestically. So, from our insights, we'll also recommend those as some of the most opportunistic areas of innovation and manufacturing at the moment.
Yeah, also bringing in a policy perspective for hard to get sectors such as cement or steel, so to speak. government has already doubled down with the National Hydrogen Mission and the National Mission on Green Steel. And those policies can be leveraged by startups to basically get a competitive advantage in terms of rolling their products out. And if they can make sure that they can provide viable solutions. The decarbonization of transportation is on the way, and I don't think they can be considered as hard to abate. But other sectors, industrialization sectors, there is a huge opportunity because government is currently providing a lot of incentive to that, just from the policy perspective.
Got it. Thanks, Shruti. Thanks, Abhinandan. I think the next question on chat we have from Abhishek. What are your views on the HVAC cooling tech and building management system industry in India? Particularly about the current trends, challenge, as well as the potential.
Right. So our team's work is not uh, cover HVAC cooling tech, so to speak, in the scope, but I'll still try to answer the question in a rudimentary sense in terms that uh, for HVAC specifically and basically cold storage and cooling value chains, government also has come out with policies for the same from a policy perspective. And there are demand incentives vis-a-vis, for example, the policy on white goods, the PLI on white goods, which can be leveraged into building the supply chain for the same. But with respect to the current trends, I think we do not cater to that. But the potential for improvement is huge because of the demand sectors that require this intervention. Efficiency as well as energy efficiency is one of the aspects which come about when we talk about cooling. But other than the energy sector, there is food, there is also beverages, there is cold storage requirement for to and fro of freight as well, which is required in this sector. And I think the diffusion opportunities for this are larger as compared to what we see in other specific fields such as clean energy. Building ecosystem also comes into play when we talk about the cooling opportunities. And when the government is dealing with energy efficiency in cooling, their focus is to basically reduce the uh, energy units which are spent in providing these solutions. So for more, probably we can get back to you with a more detailed answer later through our internal institutional mechanism. But for now, this is all we can say on the HVAC and cooling tech because our understanding in technology future is fairly limited.
Maybe I can add a little to that in terms of the potential, right? Currently, almost 70% emissions are related to operation and maintenance of a building during its entire lifetime. So energy consumption is definitely a major, operating expense for buildings also. And, with HVAC lighting and other systems running often inefficiently, actually. So there is definitely a need to reduce it from a cost perspective as well as energy perspective. So, with green buildings also rising, this is a technology that will definitely take up, and retrofitting older buildings with BMS will definitely improve energy efficiency and extend system life cycles and reduce waste also. Okay, just moving to the next question. With a lot of focus on semiconductor manufacturing in the country, what are your views on any innovation happening in circuit board recycling?
CEEW and our team essentially are working with the Ministry of Mines on critical minerals, and one aspect of it is recycling, in which the semiconductor circuit board recycling or chip manufacturing ecosystem plays an important role. Much of the sector right now can be termed as informal with respect to circuit board recycling, and there is a huge policy push from the government to make sure that this informality is reduced to a certain extent so that a lot of minerals which are critical to India's energy transition can be recovered from the circuit boards because they are otherwise being spent and not being utilized in the use case cycle for other use cases. So, under the National Critical Mineral Mission, for example, there is a certain component on recycling of critical minerals, and obviously, circuit boards becomes an important component with respect to retrieving silicon, copper, silver, gold, etc. And therefore, it is very important from that aspect. From a policy point, or from point of view of startups, I think the major challenge that they face is reducing the informality and increasing the technicality of the process so as to so much that there is such automation that most value can be extracted from the circuit boards. But the collection system in India is so informal right now that you cannot extract that full value. And therefore, the ecosystem needs to move towards a more upward integration and take responsibility for collection as well, rather than just focusing on processing the circuit boards which has been recovered at their facilities at their end. So I think the whole ecosystem is there to be captured, and there is a lot of incentive that will be provided by the government on this in the short term. Yeah.
Well, thanks, Abhinandan. I think we have another question, just slightly specific on if there are any policies in place right now focusing on the end of life scenario for disposal of recycling of panels, turbines, and batteries in India.
Do you want to take this?
It was right up your alley. I was thinking that you would take it up, but
All right, I'll take it up, no problem. So for end of life for battery, solar, and PV. So CW recently came up with a report on solar PV circularity, and I hope your audience can probably check that report out, in which we have
I
basically
can share a
estimated
link
how
as
much
well.
of, yeah, you can share a link on the chat, in which we have estimated how much of solar waste will be generated, and we projected a certain amount in the future, and that amount can essentially be used and recycled for other use cases, as well as in making new solar panels. So that becomes an important point. For end of life management, from a solar perspective, the focus is on the power project implementation agencies or the power project implementation companies, to make sure that the solar panels which they have deployed at their sites go for circular economy practices and go for recycling, and therefore EPR can be extended to that. There is no specific policy to that respect, but this is the trend on which the government is moving towards. For batteries, we already have battery management rules propagated by Central Pollution Control Board, and those battery waste management rules have stringent guidelines, as well as uh, compensation as well as penalties for EPR requirements, in which companies have to take responsibility of the batteries that they generate, and OEMs come into play in that respect, and therefore battery ecosystem is more robust compared to what we see in solar. Uh, and moving forward, I think it becomes the responsibility of the OEMs when we are talking about the final end product of equipment and the circular economy practices for that aspect, because the OEMs have a strong vendor system when they are trying to assemble and make a final product. They also need to have a stronger vendor system in terms of circularity, so that they would have their collection agents, collection site, and they would have their facilities where they can recycle material for captive use or send to the market through another value addition or a stack, which they can create a business innovative model later on. But from a government perspective, they think that the responsibility lies with the OEMs for batteries, and the battery manufacturers as well. And for solar, the project implementation agency, the EPC agencies, are uh, thought to be responsible. But obviously, the solar ecosystem is less mature compared to batteries in terms of circularity and end of life, and we will see a lot of intervention from the government to that end in the medium term.
Just adding to this, there are also safety hazards with the informal economy of reused batteries and recycled batteries, where if the battery management system is taken out, then there are lots of safety hazards in the way informal economy is utilizing these products. Due to that reason, as well as the potential of tapping into end of life products and extracting the mineral resources out of it and getting the circular economy of minerals and materials rolling further. Due to both these reasons, there will be a lot of interest in this sector, and it's a great area for innovation. And along these lines, I've also shared the report that we spoke of in the chat.
Great. Thanks for sharing the report. Just moving to the next question. Please comment on future of nuclear energy and energy transition and how supporting are the government policies.
So the government has just gave a huge shot in the arm to nuclear energy in India in the recent budget, with the national nuclear mission being launched. It envisages increasing India's nuclear capacity almost 170% increase from current capacity up till 2032. So they want, there is 8 gigawatts, 8.2 gigawatts of installed nuclear, and they want to upgrade it to 174% up to 2032. But the main target is 100 gigawatts of nuclear uh, which is the prerogative of the National Nuclear Mission. The focus under that has been on utilizing India's existing thorium resources for heavy pressurized reactors, so to speak, firstly. And secondly, would be developing two types of modular reactors. One they is known as SMR, the small modular reactor, which from 30 to 300 megawatts. And the second would be uh, a reactor which is known as Bharat Module Reactor, BMR, which the government is planning to basically manufacture and deploy with the help of Nuclear Power Corporation of India Limited. So a lot of focus has been going on to introduce modularity into the nuclear sector in India, and there are existing projects and up and coming projects in various states such as Rajasthan, Karnataka, Maharashtra, etc., in which we want to scale up conventional nuclear technology as well. And I think the National Nuclear Mission will cater to both the conventional technology and up and coming. 20,000 crores has been allocated for R&D for small SMR technology in India, taking a cue from developed nations such as US, UK, Canada. And therefore, there is a huge potential and a huge upside for investment in this sector going forward. Just to make another point with respect to the policy uh, in that regard would be that India will also try to amend the rules on nuclear liability, which currently falls on the supplier, and therefore to change those rules and to make sure that the compliance is up to an international standard so that more private investments can be attracted from international players as well as domestic players in India's nuclear sector. The rules may be amended in the future. So there is huge leverage and a huge interest in nuclear in India, and the sector would only go on in increase to grow. Uh, the SMR R&D budget, for example, 20,000 crores is one of the highest in the world. Therefore, India is betting huge on nuclear becoming a large part of the renewable mix in the future, and therefore there is a huge potential for the system going forward. It was in a slumber for probably a decade, or more, even more from 2010 on 14 onwards, but the recent budget has completely flipped the coin in favor of nuclear energy in terms of investment as well as regulatory changes that the government may undertake.
I think we have a slightly specific question also around how can the refrigeration industry in particular contribute to India's clean energy transition?
So essentially that integrates to the earlier question on cooling, basically refrigeration industry. uh, I think they can do
Yeah.
it in two ways, energy efficiency becoming one of them, because refrigeration becomes an important tenant for India, especially with vis-a-vis climate resilience. Energy efficiency is one angle which we can take, because appliance has to become more smarter, integrated with AI, become more efficient in terms of extracting power from the grid. That becomes important from a climate resilience perspective. Second, which refrigeration can be important for India would be in terms of the cold value chain that India is trying to create, which comes from the cooling perspective question. And indigenizing that and becoming a robust player in that would also help our manufacturing sector in the larger extent, and diffusion benefits are huge. From As the question is specifically on climate action, I think uh, you see that there are almost 78% districts of India are basically prone to climate heat risk. So refrigeration in those districts becomes very important. And for climate action, the only thing that the sector can do is deployment and scale with improved energy efficiency, so that you may not put a large burden on the grid itself, but simultaneously try to be more proactive in mitigating the after effects of what we will see due to climate change come in the future.
Got it. So I think maybe a couple of last round of questions, and this might be slightly repetitive, but I think we can end on that note as well. I think if you could just summarize some of the biggest challenges and opportunities in India for the clean tech sector in driving the energy transition.
Yeah. So in terms of challenges, one of the things that we are keeping our eyes on is a balance between deployment and manufacturing. The domestic deployment will be a very important demand indicator and a hedge against a rather volatile export market demand. and hence keeping the auctions, the deployment targets, and the manufacturing in line will be very important. For example, to sort of reach our targets, annually we need to add around 40 gigawatts of solar, if I'm not wrong, roughly, annual additions. But our manufacturing pipelines are nowhere close to that. And hence, when we are looking at value addition and supply chain integration at the end of manufacturing, those targets have to keep pace with deployment, and the entire ecosystem has to scale together. So, talking of a whole of government approach where different ministries have a general consensus in mind in taking the electricity and power sector ahead, and a general consensus between industries and academia and innovators and startups also in building things for the future, materials for the future, technologies for the future, are things that we are seeing increasingly, and collaboration across the entire ecosystem will be very important. Other opportunities may exist in exporting to emerging markets, for example, in Africa. So, while the global geoeconomic sentiment has been in turmoil and it's hard to anticipate trends, it's still very important to tap into certain demand ready markets where we can scale and increase our foothold. And lastly, I would say that many trends can still be hard to foresee in these markets, the way battery chemistries are playing out, the way the pace at which technology is developing, especially at the end of China, we saw coming up, and all of the energy and water demand that was expected to come from data centers with rapid and disruptive innovations, we can see those numbers coming down. So our future may be shaped by technologies that we are not very well equipped to predict the pace of disruption of, and we should be very prepared. And while innovation will require ambition, the execution should be based on prudence and very good risk management principles, very solid and strategic business models. And hence, there is also scope for commercial innovation in the way business models are working. There is scope for commercial innovation in how the informal economy and the circle economy work. There is space for business innovation in how different uses of solar modules in, let's say, agri PV and BIPV are evolving. So those are also very important areas working where will add to greater resilience. Some of the challenges, definitely overcapacity is a very important challenge. When we look at China, there is excessive production of many components, materials, etc. And the market is flooded with goods with artificially low prices. So staying competitive against that is difficult. However, managing demand and supply for any business would be very important, and tapping the right markets wisely and strategically again is key. And also working on business fundamentals, robust immediate commercials, and also ensuring that we are keeping in mind non-cost comparative advantages that will be very important in the future, like embedded emissions in any products and ESG regulations. Those things are becoming increasingly important. So manufacturers in India can try and build non-cost competitive advantages as well, which will give them a leg up in the market. Abhinandan, would you like to add anything?
I'll just add an anecdotal example. So basically, climate tech startups which have scaled in India have relied entirely on demand from the consumers in India, and the supply chain is very concentrated in terms of components as well as in terms of input materials. So therefore, I think the startup ecosystem, what it needs right now, not to basically invest heavily on the perspective of having an expanded market, because technology changes very swiftly in clean tech, and Shruti has pointed that out. And therefore, the prerogative of basically the ecosystem as a whole, it is to invest in innovation and domestic R&D and the productive know-how that these startups would have, which make us very independent of what China is doing, what America is doing, what Europe is doing. And if we can have a productive know-how which is Bharat-centric and indigenous, then I think the scaling becomes uh, a very uh, endogamous and not dependent upon supply, which is technology not technology agnostic. So, for example, tomorrow lithium ion vanishes and sodium ion comes into play, and everyone is basically relying on that. If India does not have the productive know-how of the same, we'll still be reliant as an import partner to other countries. and therefore the value of that innovative ecosystem in clean tech would not have been captured. And I think that becomes important lesson for us to strive for innovation, and so as to not for pumping in money just based on a business model or the demand outlook for the future.
Great. Thank you so much, Abhinandan and Shruti, for an insightful session on opportunities in clean energy supply chains, manufacturing policy, and innovation for climate action. I actually think we had a very technology and policy packed discussion, and I'm sure there are great takeaways for each participant. I would also like to thank all of the participants for your active engagement and thoughtful questions. We hope you leave today's sessions with actionable strategies to even take your venture to the next level, and we encourage you to apply for the Avana Startup India Niti Aayog Atal Innovation Mission Grand Challenge for Climate Tech Innovation and continue innovating for a sustainable future. Thank you, and we look forward to seeing you at our future events.
Yeah. Thank you, Antika, for having me.
Thanks everybody at Avana.
Thanks, Antika. Thanks, Ish.